of what we were doing before.
Yes.
So we've been looking at sequences over the past couple of weeks. And one thing that we were doing more recently is we were looking at how to find different terms in the sequence. So kind of almost working backwards from knowing, okay, so this term is in the sequence. How do we get to that term and find whether or not that is in the sequence? So before we start, we're of course going to recap what we've been doing so far. Yes. We'll start by kind of going over the things like the term-to-term rules. And when we look at the term-to-term rules, then we'll look at finding the nth term, and then we'll start looking at working backwards from our sequences as well. Okay. Although I think term-to-term rule and nth term will maybe combine that into one. So we'll go straight for the nth. Okay, let's have a look at this sequence here. So 3, 6, 9, 12, etc. What's the term-to-term rule, and how do we find the nth term of this sequence?
The term-to-term rule is add 3.
Yeah, perfect. So term-to-term rule is add 3. Good. Yeah. And the nth term?
10, 12, 10. So the starting is 0.
Yeah, the starting point is 0. Good.
Yeah, and so add 3. So 0, and then 3, 6. Yeah, 0. Add 3. Yeah, and then it becomes 3n. 3n.
3n. Yeah, perfect. How can we simplify that? Do we need the plus 0?
No, just 3n.
Yeah, perfect. Just 3n. Yeah, awesome. So what we notice here is that our term-to-term rule, we're adding 3 each time. So that makes our nth term 3n. And then, of course, we need to shift it to start in the right place. Yeah. So we have that our sequence, the first term of our sequence is 3. So the sequence, remember that that's already gone by one step. So the first step, so the starting point of the sequence will be 0.
Yeah.
Okay, good, well done. We're going to practice a few negative ones. So just not all of them necessarily, but just be prepared that there will be some negative ones. So we'll do 8, 4, 0, minus 4. Okay, how do we, first of all, the term-to-term rule?
Is subtract 4.
Yeah, is take away 4.
And the starting point is 12.
Yeah, starting point is 12.
So 8n.
No, 8n.
No, 12n. Because
not quite. So what goes in front of the n in our nth term?
The 8.
Not the 8.
4.
4. Yeah, plus or minus 4?
Minus.
Yeah, perfect. So we have minus 4n. So why do we have minus 4n? Well, we have each time we go from one step to the next step, we're taking away 4.
Yeah.
So for n, if we go n steps, we've taken away 4 times by n. So minus 4n.
Yes.
Okay, so what else do we need there in the nth term?
So we know that we've taken away 4 and the nth term is minus 4. Term-to-term rule is take away 4. We found the nth term, yeah.
So that's not quite the nth term. So you're correct in that that's how we get from one term to the next term. So that's most of the nth term. But remember, we need to shift it by the starting point. So you said this number already. Where do we put this number?
Starting point is 12.
Yeah, starting point is 12. So how do I?
We're going to subtract.
Not subtract.
Add, because.
Add.
Yeah.
Yeah. So we're always going to add that first point.
Yeah.
On.
From add 12 and yeah. So.
Exactly right. So we're going to be adding 12 on to that. Okay. So let's just check that we've got, so when n equals 1, we have minus 4 times 1 plus 12, which equals 8. So we can kind of confirm, based on the first term, that we have the correct nth term. Okay, let's do another one of these. We'll do 12, 6, 0, minus 6.
So the term-to-term rule is subtract 6.
Yeah, perfect. So term-to-term rule is subtract 6. How would you work out the nth term?
So at the starting point is 18.
Yeah, starting point is 18. So how do you combine them to make the nth term?
So minus 6n.
Minus 6n, good.
And then add it to 18.
Yeah, add 18.
It's 12.
Yeah. So it's not going to be 12. Why is it not going to be 12?
No, wait.
Can we add minus 6n and 18?
No, we're gonna do it from here. 6n at 18. So if we're gonna do a 6n and add, we're gonna start from the negative numbers. So 6, 18, yeah. Over here, look, 6 here.
Yeah.
And 12 and 18. So it's
Yeah, so that's not quite where that 18 comes from. So the 18, remember, comes from going back by one step. So the 18 is actually the 0 term. Okay, so 18 is where we start. So the reason we can't, so have a look, think about this kind of algebraically. So on the first part, we have an n. On the second part, we don't. So because we don't have the same letter, we can't add them together.
yes.
Okay? So that's why the nth term has to stay like that. We can't simplify that any further.
Yeah.
Okay? So the reason why, so minus 6n, so the minus 6 comes from our term-to-term rule. This comes from the number of steps. So n, remember, stands for number. And every time we take one step, we multiply by minus 6. Okay, so sorry, we add minus 6. If we go 3 steps, we add minus 6 3 times.
Yeah.
Okay, so what that means is if we go n steps, we add minus 6 n times. Okay? Cool. So, next part is, let's finish going through this one. So then the 18, where did we get the 18 from? What, can you explain to me why we add the 18?
So over here, the 12, yeah,
Mm-hmm.
that's all it shows us on the thing.
Mm-hmm.
To find the starting point, where it all starts, yes, you have to go back by the number you're subtracting or adding. So we added 6 to 12, which made 18.
Yeah, exactly right. So we've reversed that first step. So we're going back from the first step back to the 0 step.
Yes.
Okay, awesome. Exactly right. So, great. So that's why we add on the 18. So remember, the 18 actually represents the shift. So if we were just adding minus 6, we would start at 0. So we go 0, minus 6, minus 12, minus 18, etc. But we don't. We start at 12. So the first step is we have to kind of decide, if our first term is 12, where is 0? Where is our starting point?
Yes.
Okay, awesome. We'll do another example of this. We'll do 5 minus 2 minus 9 minus 16. Okay, have a go at finding the nth term of this one. This one's a little bit tricky.
The term rule is subtract 7.
Mm-hmm. Good.
And then, so to find the starting point, it's going to be 12.
Yeah, the starting point 12. Good.
Yeah. So
So put that together into the nth term.
so 5n.
Not 5n.
5n minus 5. Because
Remember what's the term to term rule?
subtract 7. Yes, subtract 7.
Yeah. Subtract 7.
Okay, that's right.
So what do we put in front of n?
So minus 7.
Yeah, perfect. We put minus 7.
Yeah. And then
Good. Well done.
yeah. So.
And then we put, how many times do we subtract 7 to get to the nth term?
3.
So that would take us to the third term. What if we make it more general and say the nth term? Where does that take us?
Where's that?
So minus 7 times what tells us the nth term?
4. No, 4.
So it'd be minus
3,
7
5.
n. So let's just go back over the previous one second. So this n is the general term, okay?
Yes.
So if we go n steps, how many times, in this, just thinking back to this example here,
You go to
if we're going, sorry?
to go to 18.
Yeah, so we go to 18.
So 2. No. 6, 18. Yeah. So for this one, when the nth term is 18. Yes.
Sorry, not quite. So just think about why when you write the nth term, what does that mean to you? So what does this nth term expression actually mean?
6. So it's
So try and explain what the reason we need it for.
because it's showing how much you're subtracting or adding by. Like, because you're subtracting 6 each time.
Yeah, so we're saying that the term to term rule is subtract 6 each time. But what's the point of the nth term? What does it tell us? So let's say we wanted to find the 20th term.
Oh.
What would we need to do without the nth term?
Oh yeah, I know. So because it wants, so say you're gonna find the 20th term, it's telling us how much you're finding out of it. Yeah.
Sorry, what?
It's showing how much. So if you want to find 20, and you add 20n, yes, for the nth term, the n is showing us how much we're finding out of it. If when you're doing a sequence. Yes.
Not quite. Yeah, so we have to go 20 steps, so that's correct. But every single step we're taking away 6. So to get the 20th steps, how many times have we taken away 6?
20.
Yeah, 20 times.
20 times.
Okay, so if we want to go 21 steps, how many times do we need to take away 6?
21.
Yeah, 21. If we want to go 22 steps.
22.
If we want to go general and we want to go n steps, how many times do you take away 6? Sorry?
Your voice.
Okay, sorry. So if we want to go for n steps, how many times do we need to take away 6?
No, 6 times. 6.
Not quite. So 1 step we take away 6 once, 2 steps we take away 6 twice. If we want a general step, so we can take any value of n, every step we want to take, whatever step we're on, we want to take away 6 that many times. Okay?
Yeah.
So if we want to go n steps, we want to take away 6 n times.
Yes.
Okay, so think back to a couple of weeks ago, we were looking at writing formulas.
Yes.
Okay? So when we're writing formulas, we use a letter to represent something that we want to change, to be able to change. We'll just go over one example that we looked at that time. So we said